Welcome back. In this session, we'll see a few more things about pointers. We shall see methods of memory allocation, then dynamic operators, operations on pointers, and memory leak. So these are the few things related to pointers. So what are the methods of memory allocation? What is memory allocation? What is memory allocation? Memory allocation is the process of reserving memory required for data in a program. The process of reserving memory required for a program is called memory allocation. Memory allocation. There are two methods for memory allocation, namely static memory allocation, and dynamic memory allocation. So, for reserving memory required for a program, there are two ways. One is called static memory allocation and the second one is called dynamic memory allocation. If the memory allocation is done before program execution, it is called static memory allocation. See, actually the programs are set of instructions stored in secondary storage device. When a program is to be executed, those instructions are loaded to computer's memory, that is RAM, into the RAM. Then immediately after loading these instructions to memory, the required memory locations for storing the data are also reserved prior to execution of the program. So such a reservation, such an allocation of memory is called static memory allocation. If the memory allocation is done before program execution, it is called static memory allocation. So the memory once allocated is, once done is done. We cannot allocate more memory during program execution. This is one of the limitations of static memory allocation. Suppose we have allocated 10 locations and we are expecting actually maximum of 10 locations, 10 data to these locations. Suppose some situations occur that requires we want to store 15 data. In that case, that program fails. We cannot reserve more memory in static memory allocation during execution. Also, another drawback is if we have reserved, suppose we have reserved 100 locations. If you are using the 100 different 100 data to these all these locations, then it's okay. Suppose when a program is being executed, we have only 50 data to these 100 locations reserved, then in that case that 50 locations are wasted. So this is the drawback of static memory allocation. In our programs we have learned like this. We make statements like this: float, avg, int, count, etc. So these type of declaration is static memory allocation. Here memory for avg is reserved before program execution. Space for memory locations required for the count, variable count, is reserved before memory allocation. So this is static memory allocation. Here we are interested in dynamic memory allocation. Why? Because it is something related with pointers. In dynamic memory allocation is done during program execution. So the required memory is reserved whenever it is needed. So there is no chance for wastage of memory. So there is no chance for memory underflow or memory overflow. So this is done, dynamic memory allocation is done during program execution. Dynamic memory allocation is performed with the help of pointers and dynamic operators. That is our next topic, dynamic operators. So the next topic is dynamic operators. In C++, we have two operators known as dynamic operators. They are new and delete. The two operators that are known as dynamic operators are new and delete. These are two keywords. We must use small letters. New and delete are dynamic operators in C++. This new is used for memory allocation. This delete is used for deallocation of memory. Deallocation of memory. New is used for allocating memory dynamically, and delete operator is used for deallocating the allocated memory using new operator. So these are the two dynamic operators in C++. New for allocating memory dynamically and delete for deallocation of memory, which are reserved using new operator or in dynamic fashion. Now, how we will allocate memory in dynamic fashion. Next is how we can use these pointers for allocating memory in dynamic fashion. Consider a pointer of type short int. We know integer in GCC compiler it uses 4 bytes. Short integer which uses only 2 bytes. Such a pointer we are using short int star ptr. Or if you have any confusion, let's change that. Let it be int star ptr, integer point. Now let us see the memory organization. Let this be the RAM. See here, pointer ptr is created in static fashion, not in dynamic fashion. So we have created a pointer of type integer. What happens? We know ptr is a pointer, but it has some privileges, a special pointer, a special variable. So it is created, some bytes are reserved in memory. This entire space is known as ptr. Since it is a pointer, it can store, this area can store address of memory location. Now, we are writing a statement like this. ptr equal to new int. ptr equal to new int. This is the statement for dynamic memory allocation. By this statement, we are going to reserve memory during execution time, during program execution. This is of type integer, so we will reserve 4 bytes. The system will reserve 4 bytes. So the memory allocation will be something like this. 4 bytes will be reserved. 1, 2, 3, 4 bytes. 4 bytes will be reserved. Suppose this has an address, say 5001, 5002, 5003 and 5004. 4 bytes are used. Each bytes are numbered. This is the byte address or memory address. So this area has no name. This 4 bytes has no name, but that 4 bytes are reserved as a single unit. Then the reserved memory, the base address of the reserved memory is stored in ptr. So this ptr will contain 5001. Here new operator is used for dynamic allocation, dynamic memory allocation. Int is used by, so that 4 bytes are reserved. The base address of those 4 bytes is, that memory location is stored in ptr. So we will draw like this, which means this ptr points this location. We will draw it like this. This is ptr. These are the 4 bytes reserved. This is the pointer. Here it is 5001. These 4 bytes are 5001, 5002, 5003 and 5004. Now another example. Double star p. P is a pointer of type double. Double data type uses 8 bytes. What happens? As the earlier case, here some bytes are reserved. This area is named as P. Now we are writing a statement like this: P equal to new double. P is equal to new double. What happens? 8 bytes will be reserved. 8 bytes will be reserved. 8 bytes. Similar to that of this area, this will be having some address like this, say 4050, 4051 to 4057, like this. 8 bytes are reserved. Since it is assigned to P, what happens? This 4050 will be stored here, which means these points, this area. We can draw like this. This is P. It contains 4050. Each points some 8 bytes like this. So in this way, we can reserve or allocate memory in dynamic fashion with the help of pointers. Now suppose, see this statement, int star ptr, ptr equal to new int, can be, these together can be written in a single statement like this, int star ptr equal to new int. We can write like this. This is also syntactically correct. The syntax is okay, no problem. These two statements together we can write like this. Now suppose, instead of putting semicolon here, we are writing some 450 here, like this. Int star ptr equal to new int. This is parenthesis 450. What happens? New operator, int data type. So it reserves 4 bytes. And within bracket, we are given 450, which means the content of this 4 byte, inside this 4 byte, there should be, this will be assigned. 450 should be assigned there. Then the remaining are similar to that of the previous example. Here we have a PTR, yes, here a PTR. The starting base address of this location is 5001. That 5001 is stored in this PTR. So we will draw like this. This is PTR. Here we have 5001. It points to 4 bytes. Inside this there is 450. Right? Now this location, this 450 can be accessed. How we can access that? In order to take value to this location, we can write a statement like this: cin star ptr. If we give some value, say 1000, what happens? That 1000 will move to this location. Suppose we want to print this 450, we can write statement like this: cout star ptr. So the 450 will be printed. And what happens if we write like this: cout, say ptr, just ptr, cout ptr. What happens? ptr's content is 5001, so the output will be 5001. So star ptr gives the value at 5001. Yes, ptr gives the address. So in this way, we can allocate memory in dynamic fashion. Now the next thing is memory leak. Memory leak. What is memory leak? See, it's a phenomenon that occurs when the programmer forgets to use delete for a memory location which is reserved using new operator in dynamic fashion. If a memory block is allocated using new operator, and after its use, if the programmer forgets to delete in the program, if that memory is not deallocated, it will remain as an orphaned block. The allocated memory, if it is not deallocated, it will remain as an orphaned block of memory. That memory cannot be used further if it is not deallocated. If this process continues, what happens? The number of orphaned blocks become more and more. It will adversely affect the system. That process, that phenomenon is called memory leak. If the memory allocated using new operator in dynamic fashion is not deallocated using delete operator, it will cause to generate orphaned memory blocks. These orphaned memory blocks will adversely affect the system. This phenomenon is called memory leak. What are the reasons for memory leak? The reasons are: 1. Programmer forgets to use delete. Programmer forgets to delete or deallocate the memory location. He is forgetting to use the delete operator. The second one, bad or poor logic of program. Programmer has taken care to use delete, but the program, when the program is executed, the delete operator is not properly functioning. So it is due to the poor logic of the program. And third one, programmer assigns new memory block to an existing pointer before deleting, before deallocating memory block assigned to it. These are the three reasons for memory leak. Programmer forgets to use delete operator, poor logic of the program, and programmer assigns new memory block to an existing pointer before deallocating it. Suppose we have a memory PTR here and it allocated some blocks this way. Before deallocating this, the programmer performs some operation like this: PTR equal to new int, some operation like this. What happens? Another 4 bytes will be reserved and this arrow will be pointed towards this and this will be broken. So this becomes orphan. So these are the three reasons for memory leak. Memory leak creates adverse effect to the program. Now, what are the operations that can be performed on pointers? Operations on pointers. Only limited operations can be performed on pointers. We can perform addition and deletion. Addition and subtraction addition and subtraction. These are the two arithmetic operations. These are the two arithmetic operations that can be performed on pointers, addition and subtraction. Then we can perform relational operations like equal to and not equal to. These are the relational operations. So the operations that can be performed on pointers are addition and subtraction, equal to and not equal to. These are the operations that can be performed on pointers. Now, suppose we have a pointer like this. Say, for the time being we are taking short int star ptr. Short int star ptr. Ptr is a pointer. It can hold address of memory location. Suppose this contains 4020 as its content. This is of type short integer. Short integer consumes how many bytes? 2 bytes will be used. Now what happens if you write a statement like this? PTR plus plus or PTR equal to PTR plus 1. What happens? PTR plus plus means PTR equal to PTR plus 1. If you are writing a statement like this, PTR equal to PTR plus 1 or PTR plus plus, what happens? Here, adding 1 to a pointer always does not add 1 to that pointer. The addition depends upon the size of memory or the bytes required for the data type. Here short int uses 2 bytes. So this 2 will be added to this content. So PTR plus plus or PTR equal to PTR 1, after the execution of that statement, this will become PTR 4022. Again, if we add one more addition, we are performing one more increment. PTR plus plus is performing. That is PTR 1, adding 1 to PTR. What happens? It becomes 4024. If you are writing a statement like this, PTR equal to PTR plus 5. PTR equal to PTR plus 5. Let 4020 be the present content. PTR equal to PTR plus 5. What happens? 5 times 2, that is 5 into 2, that is equal to 10, will be added to the current PTR. So 4020 becomes 4024 becomes 4034. So this is pointer arithmetic. Now what happens if we perform like this? PTR equal to PTR minus 3 to this PTR equal to PTR minus 3. From 4034, it reduces 3 into 2, that is 6. So it becomes 4028. So adding a 1 to a pointer will add the number of bytes required for the data type of that pointer. If it is integer, it will add 4. If it is a short integer, adding 1 will add 2. If it is a double pointer, adding a 1 will add 8 to the pointer, to the content of the pointer. If we subtract 1, what happens? If it is a short integer, it deducts 2. If it is an integer, it deducts 4. If it is a double, it deducts 8. If it is a character pointer, if you subtract 1, it will subtract only 1 because the character, the size of the character data type is 1. So this is pointer arithmetic. Now we can only compare like this. int star p, int star ptr. We can make statement like this: if p equal to ptr, we can write statement like this, or if p not equal to ptr, we can write statement like this. We cannot compare if p greater than ptr, less than ptr, less than or equal to ptr, greater than or equal to. These comparisons are not allowed. So we can only check for equality and non-equality. So these are some few more points about pointers. We have seen the static and dynamic memory allocation. With the help of pointers, we can allocate memory in dynamic fashion. And we have new and delete operators. New operator is the dynamic allocation operator, and delete is the dynamic memory deallocation operator. And there is a phenomenon called memory leak. If we do not properly use delete operator, it will create an adverse effect called memory leak. And we have seen the operations that can be performed on pointers. We can perform addition and subtraction, as well as relational operation equal to and not equal to. We can check for equality and non-equality. So thank you. That's all for this session.